How many solutions with the following equations have? Will the following equations have? So the first one, we got y equals 2/5 x plus 3, and the second one, y equals negative 2x. The only thing we got to do is look at the slopes for these ones. So these are both in slope-intercept form. So our first slope is showing as 2/5. And then the second slope is showing as negative 2. All right, so since the slopes are different, this will have one solution. That's it. That's all we got to do for this one solution. Now, if the slopes were the same, then we have to look at the y-intercepts, which would be these two values. If they're the same and the y-intercepts are also the same, then you'd have infinite solutions. If you have the slopes are the same, but the y-intercepts are different, then you have no solutions. But when the slopes are different, like they are here, there's only one solution. Okay, there's our objective. I can use substitution to solve a system of equations. So last two lessons, we looked at graphing a system of equations and then just finding the intersection. Now we're going to be using a different method, substitution, to solve these. Take 30 seconds, copy this down, then we'll get started. All right, so just like solving a system of equations with graphing, these equations are still going to be an ordered pair on the graph, because even though we're not graphing the lines, if we were to graph them, it would be the intersection of the two lines. For example, this red and purple line intersect here. That would be our solution. Now, we've talked about this before. It's because this green point right here would make the red line equation true, but it would also make the purple one true as well. So, but the way this sets up right here is it's the only ordered pair or location on the graph which would make both of them true. We've seen this before already, where maybe a point is right here. Okay, well, that would make the red one true, the red equation true, but it would make the purple one false because it's not actually on the purple line. Or sometimes we may test a point out here, and then it makes both of them false. Okay, so we're looking for the ordered pair, and then that is how you're going to have to enter your answers. On the assignment, it looks something like this, and then you just kind of enter, like that. They'll have a box here and a box here. So you got to enter the x and y value. We know that the first one is the x value, and then the second one is the y value. Okay, this is a really nerdy way to define substitution, but this is what we're going to do. Now, the first step right here, manipulate an equation so that one variable is on its own side with the equal sign. Sometimes we won't have to do this. Okay, so if both equations, maybe one of them sets up like this, y equals some stuff, or maybe it equals, it's like x equals some stuff. It doesn't matter which one of these it is. As long as one of the equations is in this, either one of these formats, then we can use substitution. And usually substitution is the easiest method to use. But the first step says, make one of the equations in this format. Well, if they already come in that format, we get to skip step one. Step two, determine what one of the variables equals an expression, which if it shows up like this, then if it's y equals, then we know we're looking at replacing a y. If it's an x equals, then we know that we're replacing the x. That may not make sense now, but hopefully it will by the time we finish, because once you know that you're replacing y or x from these formats, then we go to step three right here, and that's when we go to the other equation and actually replace the variable with whatever garbage this equals. Okay, sometimes it'll be like two terms, sometimes it's one term, sometimes it's just an individual number. We won't know until we get to the examples. Then once you replace that, then you have a one variable equation. You're just going to solve for the unknown. That means you may be using distribution, combining like terms, and then principles of equality to create zeros and ones. To isolate your x's, that would be zeros, and then you want to make your coefficient 1. That's the last step we do. Okay, then once you know that value, because you would solve for the unknown, then you have an unknown, then you replace it into either one of the equations and get the other value, right? Because remember, the ordered pair is the solution. So if you have an x value first, like you solve the equation here for an x value, then you have to solve second for the y value. But you know the x value, so you can just plug it in to either one of the equations. Or if you have a y equals equation, then you plug that in, or I apologize, then you'd be solving for x. But if you have an x, then you'd solve for y first, and then you have to, once you get that y value, then you go back and replace all the y's with that value and solve for your x. Last thing you should do is to check your answer, just to make sure it makes both of them true. Usually the calculator is a good way to check this stuff. So again, this is all new to us. Well, actually, it's possible we did some of this in 8th grade. But if it is new, this may not make a lot of sense, but hopefully the examples will. So remember, our first step would be to change one of the equations into a y equals equation or an x equals equation. This equation is already y equals. And this equation is already an x equals. And it doesn't matter which side the x is on or which side the y is on. We don't care if it's an x or y equals, but some students say, well, you can't replace x because this one equals x. Well, you could write it like this. Or if you wanted to, it would be the exact same thing to rewrite it like this, if that makes you feel better about the equation. These two are exactly the same, all right? Now, maybe we knew that, maybe we didn't. Let's say we didn't notice that or even knew that, which would be fine. Then you'd probably be looking at y equals and replacing the y equals here, this y with whatever this y equals, okay? So here's what I mean. Y equals this stuff. In fact, I'll put it in parentheses, okay? So this y over here is going to be the same exact stuff that this other y is equaling. So that y, the negative 6y equals x, I'm going to replace the y with what it does equal, 1/5 x plus 11/5. All right, so I've substituted the y. I've replaced the y with what it actually does equal here, over here. Now we apply the rest of the equation, so that was negative 6 times y, so times that parentheses equals the x. So we have a one variable equation. I've got an x on both sides, that doesn't matter. But all I've got to do now is use my solving equations, strategies to solve this one, which I will now do, because I can take the negative 6 and distribute it into the parentheses there. So that first would be negative 6 times 1/5 x's. Okay, so how many x's does that give me? That'd be negative 6/5 x's. And then I've got the negative 6 distributed or multiplied by the 11/5, which would result, let's take that back, that would result in negative, as a fraction, negative 66/5. Now, if you wanted to use the decimals here, that's fine. You're going to get the same answer either way. But I like the fractions, so I'm going to keep them. So this is the equation after the distribution, just like we've seen before with solving equations. But what I have now is I've got x's on the left and I've got x's on the right. So I've got to use principles of equality to zero out some of these values. So principle of equality setup, right? Whatever I do to one side, I've got to do to the other side. And right now, what I'm going to do is put all my x's on the right and my numbers on the left. Now that's unusual for me because I usually put the x's on the left and the numbers on the right. The reason why I'm doing this is because I've got all my constants on one side. So I can set it up like this. So hopefully after this first principle of equality, you'll see why. So my negative 6/5 x, what I'm going to do is zero that out by adding 6/5 x's. But if I do it to one side, I've got to do it to the other side. So plus 6/5 x's. And that x is actually 1x. All right, so what happens here? Well, we've zeroed out the negative 6/5 x in red. We can now drop the negative 66/5, which equals 1 plus 6/5 is going to be 11/5 x's. And again, you can use your calculator to do that. Just do 1 plus 6/5 on the calculator. You might have to push math enter, enter to get rid of the decimal, unless you want to keep it, which is fine. But now that I have this, one last principle of equality will solve it. But to go back, this is why I put the x's on the right, because if I put x's on the left, numbers on the right, I'd have to use two principles of equality. So I just took a bit of a shortcut there. And now I'm ready to make my coefficient of x a 1. Okay, so we're going to make this a 1x. And that is 11/5 x right now, but I'm going to make it a 1 simply by dividing it by itself. Okay, anything divided by itself is 1. But if I do it to one side, I've got to do it to the other side. So negative 66/5 divided by 11/5. If you're putting this in the calculator, you'll want to use parentheses around the 11/5. And we should get negative 6 out of that. Now, that's only half the answer, right? We go back and we say, well, remember, the answer is an ordered pair. So we're expecting it to look like this with parentheses, with an x on the left and then the y second on the right. And we just found the x value is negative 6. So our answer has an x value of negative 6. Well, since x is negative 6, we just got to solve for the y. It doesn't matter which of the two equations we use to solve for y. I'm looking at this one just because it looks easier to work with. Okay, so let's go back and solve for y. I'm going to use the second equation. You can use the first one. You should get the same value. But it is negative 6y equals x. But right now, we just found that x should be negative 6. Okay, well, if that's true, we got to solve this equation, which we will. And there's only one principle of equality to solve it. So the negative 6y, I'm going to make a 1y. And that would equal whatever it is. So to make that a 1, we'll take that negative 6 and divide it by negative 6. But if I do it to one side, I'm doing it to the other side. And I'm showing the division different because it doesn't matter. But yeah, negative 6 divided by negative 6 is 1. But over here also on the right, negative 6 divided by negative 6 is also positive 1. Now really, we can make that just a regular y instead of, we can make it a phantom 1y. But right now, we're pretty sure the y value is 1. Okay? So this means over here in this equation, the first equation, if you replace the y with 1 and the x with negative 6, then you end up with a true statement. So the way we've done this already, we've pretty much checked the second equation, right? And since it's true, it means that this point is on the line. The ordered pair, negative 6, 1, is on the line if you were to graph it. Which I don't know that everyone wants to graph it, but maybe you do. But it means that the second equation should also be true. Okay, so we're just checking right here. We're not actually necessarily solving. And I'm going to use a calculator to check this. But the equation right now is y equals 1/5 x plus 11/5. And again, I'm just checking to make sure that this will be true with the equal sign. Because if it's false, then this ordered pair, negative 6, 1, does not actually end up on the line. So the x value we have is negative 6. And the y value we have is positive 1. And now, I check this to see if it's true or false. If it's true, then we're good. So like I said, I'm just going to put this stuff on the right. That's 1/5 times negative 6 plus 11/5. And when I do, put that in the calculator, I get 1. Well, 1 does equal 1. That's true. If it equaled anything other than 1, then it would have been false. But it is true, which means we have, in fact, found the solution. So we will use substitution on this one. And yeah, you could graph it. But I do not believe that you'll be able to see that ordered pair on the graph. Doesn't mean the calculator won't do it, just you won't be able to see it. So substitution should work pretty well for this one. Now the thing about this two equations, it's saying y equals 6x, but also y equals negative 4x minus 50. So again, there is no need to solve for y equals or x equals on either one of these. They're just both y equals. So what I'm going to do, and you don't have to do this, I'm going to take this y as 6x, and I'm going to replace this y with that value, 6x. Now, if you'd taken this y, negative 4x minus 50, and replaced it here, you'd get the same answer. It's going to be exactly the same thing. it's just going to switch the sides of the two expressions. So that y, I'm going to make it a 6x. And since there's no other operations with that y, I'm going to keep it out of parentheses. But now, this 6x, because it used to be y, it used to be y equals negative 4x minus 50. But now I've replaced that y, I've replaced this y with 6x. So instead of it being y equals, it is now 6x equals negative 4x minus 50. Same exact equation, but over here, this told me what y is, and that is 6x. So I now have an equation that I'm going to solve for the x. Now this time, because I'd like to make this fairly easy for myself, I've got x's on both sides, but my constants, all my constants are on the right, so I'm going to keep them on the right. So this time, yeah, I'm going to put the x's on the left, numbers on the right. Do you have to do that? No, you do not. If you wanted to keep your constants on the left and x's on the right, that's fine, but you're going to have to use two principles of equality to do it. So, going through the term, 6x is on the correct side. It's on the x side. The negative 4x is on the number side. But it's got an x, so that can't be there. We're going to have to zero that out by adding 4 x's. All right, now if we've done this correct, that should zero out the negative 4x in black. But here on the left, how many x's is that? Well, 6 plus 4 is 10. 10 x's. Negative 4x's plus 4x's. That zeroes out as we had planned, and then we can drop the negative 50. Now, I think this last part, maybe some of you could do in your head, but either way, this next step here, we're going to make that 10x a 1x. So how do you make a 10 and 1? You simply take it and divide it by itself. But if you do it to one side, it's still a principle of equality. You got to do it to the other side. 10 divided by 10 is 1. Negative 50 divided by 10, you can put that in the calculator, negative 5. Okay, so my answer, I'll put this down here. We have an ordered pair, and right now we have an x value that's negative 5. That is my x value, which means it should make both of the equations true, and we just have to solve for the corresponding y value. Well, it doesn't matter which of these equations you use. This one it's smaller, so I'm going to use it, all right? So let's take that y equals 6x, but we just found the x value is negative 5, so I'm going to take the x, and I'm going to replace it with negative 5. All I have to do at this point is solve, which, if you'd use this equation as well, you'd just do the same thing. I'm going to use that equation to check, though, and now what I get from here, 6 times negative 5 is negative 30, and that is my corresponding y value. Nothing else to do there, but to go down here, and in the ordered pair, it should be a y value that's negative 30. Okay, so this equation, if you replace x with negative 5 and y with negative 30, that's true. That's what this tells us right here. But I still need to check the other equation. So I'm going to check the other equation. Y equals negative 4x minus 50. And I'm going to replace the x with negative 5. And I'm going to replace the y with negative 30. After this, all I've got to do is check to see if this is true. Because if it is, then the second equation would be a solution as well. The ordered pair would be a solution for that. So I got negative 30, nothing to do with that. It should just equal, in my calculator, I've got negative 4 times negative 5 minus 50. Yep, it's negative 30. So since that's true, that means we know that we have in fact found the solution to the system of equations. Let's do this one together. So we're going to use substitution to solve this one. We just see that both equations are fairly long, right? Like this one's got 3 terms in the equation. This one has 3 terms in the equation. But one of the equations is already set up as y equals some stuff. So I don't have to change any of the equations into an x equals equation or a y equals equation. That's great news. What I have then is this y equals negative 2x minus 5. Okay, I got that y equals. So for my other equation, I'm going to do this a little different. It's the same, but I'm going to show it a little different than the last examples. The other equation right now is 5x minus 9y, and this equals negative 24. But over here, we know what y is, and that is y is negative 2x minus 5. So I'm going to take the y in that equation, and I'm going to replace it with what it is in the other equation, and that says that it is negative 2x minus 5. Okay, so clearly, this equation sets up where I'm definitely going to need some distribution on this. Maybe even some combining like terms. Let's find out. So first up, I'm going to have to distribute this negative 9 into the set of parentheses. And remember, distribution is multiplication. So this is going to be negative 9 times negative 2x's. Now that's going to be positive 18x's. And then next up, we would have distributed the negative 9 to the negative 5 as well. Okay, now this is where a lot of students make a mistake. They say, well, this is 9 times negative 5, and they'll get negative 45 right here. It's negative 9 because of the minus sign right there. So don't forget that part, otherwise you're going to make a mistake. It's going to be plus 45. So that's all the distribution we have. So we got the rest of this, though. So that's 5x plus 18x's plus 45 equals negative 24. Okay, just going back to Unit 1, where we were solving lots of equations, and we loved it so much. So right here, I've got x's on the left, which I need to combine. So how many x's is that? Well, that's 5 plus 18, which is going to be 23 x's. Okay, we still got the plus 45. We didn't have any like terms to combine it with, and this equals negative 24. So we're at the point where we have all the x's on the left, but we've got constants on both sides. So we're going to have to use the principle of equality now to isolate that 23x, which means the plus 45, I do not want that there. So I'm going to put my x's on the left, numbers on the right. So again, the 23x, that's okay. It's on the x side. The 45, no x term. So it's not okay. You have to zero that out, minus 45. But if I do it to one side, I've got to do it the other side. So my 23x's, yeah, it just drops. And 45 minus 45, yeah, that's 0, just as we had planned. And then negative 24 minus 45 looks to be negative 69 right there, okay? So this equation now, here at the bottom, has all the x's on the left, all the numbers on the right. The last thing I got to do is solve for x right there by taking the coefficient, right, because we want to make this 1x. I'm just going to divide it by itself. It's just if I do it to one side, I got to do the other side. So when I do this, negative 69 divided by 23 ends up being negative 3. Now that should be the x value in the ordered pair, negative 3. So put my answer down here again. Okay, we got an x and a y value. We just found the x value should be negative 3, at least if we did the work right. Now, like I said before, though, there's a lot of steps there. Maybe we made a mistake, which is why we always check in the end, just like I did on the last two problems. So if x equals negative 3, I'm going to take that second equation. So I need to take this second equation. Let's go and write it in. Y equals negative 2x minus 5. But we just found an x value down here of negative 3, right? We already put it into the ordered pair. So I'm going to take the x up here, and I'm going to replace it with the x value we found, which was negative 3. So let's do that. There's the x. I will now replace it with negative 3. Okay, at this point, all I've got to do is solve for y, and actually, all of this stuff right here, I can put into the calculator. That will give me a corresponding y value. So let's see, that'd be 6 minus 5 should be 1. All right, so that's corresponding y value should be 1 right there. Now that means, up here at the top, if you replace x with negative 3 like we did, the corresponding y value should be 1. Then you'd get a true statement in this equation. But now we've got to check in this equation as well. So I've got to go back to the first equation now. And I'm going to check that first equation. So it's 5x minus 9y equals negative 24. Well, we found that the x value, it should be negative 3. So I'm replacing the x with negative 3. And then we also found that the corresponding y value should be 1. So I replaced the y with 1. All I've got to do now is check for truthfulness. So I've got my question mark over the equal sign. So this whole part right here, again, I would just recommend putting that into the calculator, and we'll see if it actually does equal negative 24. So it'd be negative 15 minus 9. Yeah, that's negative 24. Last time I checked, that was true. Negative 24 does actually equal negative 24, which means we have in fact found the solution. So y equals 2x, and then we got 5x plus 5y equals negative 15. Again, since we're substituting, this y equals 2x stuff, especially when it's one term, y equals a term, one term, it should be pretty easy to just replace this y with that term. Okay, so I'm going to take that 2x, and in the second equation, I'm going to replace it as the y. So the y, instead of it showing as a y, I'm going to show it as a 2x. Now I'm putting in parentheses because there's other stuff that's being operated on it. So let's show that as well. This would be 5x plus 5. That's 5 times the 2x, just like it was 5 times y. And then this would equal negative 15. So this is the equation that I have to solve. All my x's are on the left, which is great. But first, I would need to distribute this 5 to the 2x. Now, why am I using distribution here when it's just straight multiplication? Because distribution is multiplication. So that's what I'm doing. 5 times 2 x's, how many x's is that? 10 x's. So I got a plus 10x right there. I still got the other 5x, and this still equals negative 15. So my new equation after the distribution or multiplication, 5x plus 10x equals negative 15. All of my x's are on the left, so 5x's plus 10x's. 5 plus 10, that'd be 15x's. And this equals negative 15. The division here is going to be great because we're just dividing something by itself. But it's the last thing I need to do to make this a 1x. So 15, I'm going to divide it by itself, divide by 15. But if I do it to one side, I've got to do it to the other side. So you can see there was no need to make zeros on this equation. But we did need to make that 1 right there. So negative 15 divided by 15 is going to be negative 1. So in my ordered pair solution, with an x and a y, we just found that the x value should be negative 1. Well, if the x value is negative 1, then I can go to the first equation, which is y equals 2x. And I should be able to replace that x with negative 1. So I put this in the calculator, 2 times negative 1, and I see that y then should be negative 2. So I can say in my ordered pair solution, the y value should be negative 2. Now this means in this equation here, if you replace the x with negative 1, we got a y value that was negative 2. That should be true, but I still need to check that second equation. So let's go ahead and check it. Okay, we've got 5x plus 5y equals negative 15. And we already solved for x. We found that was negative 1. And we just barely solved for y, which should be negative 2. So question mark over the equal sign means I'm just checking to make sure this is true. And yeah, all this should equal negative 15 still. But all this stuff right here, 5 times negative 1 plus 5 times negative 2, I would just put that in the calculator. And when I do, we do get negative 15. So since this is true, we know we have in fact found the solution. Now you'll have to keep in mind, we found the solution on this one. But if we had made any mistakes, we may get to this point and find it's false. If it is false, this means that somewhere in here we made a mistake. And then we'd have to go back and check it. Thank goodness we didn't have to. But if we did, we'd have to go back and check it just to fix everything, okay? I can use substitution to solve a system of equations. That's it. So we have that process. Again, there's lots of steps in the process, and it's possible to make little mistakes. Usually, if you find out that you've ended up having a false statement when you check, it just means that you've made a small mistake somewhere. You just got to go back and find out where that is, and then you make little corrections to fix it.